Let's take a look at the case where the sine law has an ambiguous case where we aren't actually sure which triangle we have. Here I have an angle alpha, or from the vertex capital A, and opposite that I have a side length of 7.4. Across from C I have 10.18, and then I don't know angle C. I also don't know angle B or side B. This angle right here, C, if I know that it's an acute angle, then I'm in good shape. But if I don't know, I actually have two possibilities. Let me just show you here. I'm going to draw a circle from B to C with a center B and the radius BC. And then where it intersects over here, just put a point there, and I'm going to draw a little line segment. BD now has the same length as BC. Let me just remove this circle so you can't see it anymore. And now I have another side, BD, that is the same length. There it is, 7.4 as BC. And so if, for example, I knew I had a triangle with an angle 42.71 and then two sides 10.18 and the opposite side 7.4, I could have ABC, but I could also have ABD with this obtuse angle here, this angle that is larger than 90 degrees. So it's important that you know if your angles must be less than 90 or could be greater than 90, like this one here, because this angle and this angle have the exact same sign, S-I-N-E sign. That trig value, that trig ratio is the same, and so you can find a short side AD or a long side AC that will give you the same they have the same sign on this angle over here. And so if you're only dealing with acute triangles, this works fine. If you start to get into obtuse triangles, you have a problem. You can also check the lengths here. See, this length BC is shorter than AB. If you try to adjust things to make it longer, I'll just stretch C down here. You can see my construction will break because you don't have that problem anymore. Okay, so the ambiguous case happens when you end up with this sort of opposite short side compared to the other known long side, and you could end up with an obtuse or an acute angle.